candidates. Welcome to this science session. I'm teacher Habib, and this time we are going to talk about the principle of moments. So as you're very well aware, we are still looking at levers, and this one applies to the levers. So when we say the principle of moments, we are talking about the rule that governs the way levers operate. And the first one is right here, and it states that the load force multiplied by the load arm is equal to the effort force multiplied by the effort arm. So alternatively, we can state it like this, and we say the sum of the clockwise moments is equal to the sum of the anti-clockwise moments. So here we can first define a moment, and we say a moment is the product of force and its perpendicular distance from the pivot. So any force, take an example of this question, any force, for example this one, multiplied by its perpendicular distance from the pivot is what we call a moment. So what we mean here is that the moments this side should be equal to the moments the other side. So this is our first example where we are required to find the weight of X, the unknown, this side of the box. So as we deal with levers, we should know that the load is always nearer to the pivot. So whatever is heavier is the load. It is always nearer to the pivot, and then whatever is lighter is the effort, and it is always far from the pivot. So here we shall say load times the load arm is equal to effort times the effort arm. So I think you can see that this is the load that we have. So for the beginning, we may neglect the units, and we say 50 times the load arm is 2 meters, and this one will be equal to 4. X times 4. So X represents the effort, and then 4 meters will represent the effort arm. So here we shall have 100 will be equal to 4x. Therefore we can interchange, and we say 4x is equal to 100. So at this step we are supposed to make another step where we should divide 4x out of 4 will be equal to 100 out of 4. So this 4 will cross out with that, and they will give us 1. And then by 4 here we shall have 1, and by 4 we shall have 25. So we can say that our x is equal to 25. But then we have to look back and see what we are looking for. If it is distance, then we shall put meters. But in this case, we are looking for a weight here, and this weight has been given to us in kilograms. So therefore, we shall also put kilograms here. Meaning that when we get this force multiplied by this arm, and then we get this force and multiply it by this arm, we shall be able to get equal answers on either side of the lever. We can prove it, and we see if we get 50 times 2, it should be equal to our answer which we've got as 25 times 4. So this is 100, and this is also 100. So this one just proves to us what we have just learned about the principle of moments. The sum of the clockwise moments is equal to the sum of the anti-clockwise moments. Or when we get the load force and multiply it by the load arm, we shall get an answer that is equal to the effort force multiplied by the effort arm. We can take another example here. At times they can give us this. In mathematics we call them word problems, where you need to interpret, come up with an illustration that will help you to reach the answer. So a man weighs 60 kilograms force, and then he sits 1.5 meters from the pivot of the seesaw, how far will a boy whose weight is 30 kilogram force sit for them to balance? So you can see in this question, we are required to find some distance. So if we try to illustrate it, this is the man, the weight of the man. This is the distance between the pivot and the man. Here, this is what we are looking for. The distance between the pivot and then the boy, who weighs 30 kilogram force. So here we shall say load times the load arm should be equal to effort times the effort arm. Like we've said, the load is always heavier. We shall have 60 kilogram force, but we may neglect the units for the beginning, times 1.5. This should give us 30 times x. So we shall have 60 times 1.5 is equal to 30x. So you can see that this is a decimal fraction, which we need to first change to a common fraction. Therefore, we shall say 60 times 15 out of 10 should give us 30x. So when we cross this 0 with this one, we shall remain with 6 times 15. And this will be equal to 30x. Therefore, this one will give us 15 times 6. This is 30, we write a 0 and we carry a 3. And then this is 6 plus 3, that will give us 90. So 90 will be equal to 30x. We can bring x this side. 30x will give us 90. And then we divide both sides by 30. When we cross this one with this one, we shall get 1. And then by 30, this is 1. And by 30, this is 3. Therefore, our final answer will be that x is equal to 3. But then we have to look back and we know what we've been asked. If we are looking for the distance, we look at the units right here and then we put the same units. So we shall have 3 meters. That will be our effort distance. Now, at times, for example, you can see this is point A and this is point B. At times, we may not be asked this distance, but then they may say, find the length of the rod, the whole rod from point A up to point B. So we shall first find the load, the effort arm, like we've done, and then after that, we shall add it to this one. So therefore, we shall say 1.5 meters plus what we've got as our answer, 3 meters, and this one will give us 4.5 meters. And that brings us to the end of our session. Thank you very much for being part of this session. The activity for this work will be uploaded on our Edmodo platform, and then what you have to do is download and then answer the question and then you submit. Thank you very much.